This video demonstrates the use of viciLab to create a 2-to-1 multiplexer hardware prototype on a remote FPGA and a GUI. Download the viciLab application, software and example 2-to-1 multiplexer VHDL code using this link. You may have to log on to viciLogic using your username and password. And there are 3 steps: download the application software, download Xilinx PlanAhead electronic design automation tools, and then the steps to execute the viciLab. So the first has a link to download the viciLab application software as a RAR file. When it is unzipped, in this case to the folder downloads viciLab, 2 folders exist. Having done that, go to the Xilinx EDA tools, install them on the PC. An instruction sheet details the links for the Xilinx free webpack, PlanAhead tools, and how to install. The third is to execute the viciLab applications. m21.vhd is provided as an example VHDL code inside viciLab design examples in the combinational folder, multiplexer subfolder, m21 and VHDL. Open using Notepad++. Here illustrates the entity of the VHDL, the architecture, and the function of the multiplexer described in VHDL. There's also a drawings folder which contains one picture of a multiplexer symbol and input and output signals it's used in creating the prototype GUI, and can be seen here. The viciLogic applications folder contains 2 subfolders. The parser is used first. Scroll within the parser folder to vicilogic.exe and execute. The viciLab tools use the Xilinx PlanAhead installation on your PC. Check that the config.ini file in the parser folder has the PlanAhead command pointing to the correct installation folder for your Xilinx software. Here, import a VHDL file, the m21.vhd, from the design examples combinational multiplexer m21 VHDL folder, not .vhd file. This reads that VHDL file and demonstrates the input and output signals. This application takes the m21.vhd and it connects it to a core. The core has an Ethernet interface which communicates to and from the web application. The core also has other elements such as display controller and registers for input signals and output signals which relay the signals inside designs to and from the web application. The process of linking to the core and connecting signals from inside a user design to the core is automated. The user can select any of the internal signals and connect them to the displays on the module. The module in this case is a Nexus 3. So the user selects a signal, in this particular case signal cell, and can connect to the display LED, in this case LED 3, from LED 3 to LED 3 because it's a single wire, single bit. And that is then viewed on the connections window. Click again, and this time connected to the 7-segment display, segment 3, the left one, bit 0. So that means the value of cell will display both on LED 3 and 7-segment display 3. This is repeated for mux in 1, mux in 0, and mux out. The LED sequence being cell, mux in 1, mux in 0, mux out, and the same for the 7-segment displays. When this is completed, the user generates the bitstream file, having linked the m21 VHD model to the core, etc. This process takes about 10 minutes, and provided that there are no errors, a bit file will have been created. The user can then upload the bit file to the server to allow a remote FPGA to be configured. So the process of building is now in progress. The transcript is viewed at the bottom of the screen. and on completion there are no errors, but there are a number of warnings, and these can be checked using the transcript. Uploading the bit file to the server requires a username and a password for viciLogic and automatically places the bit file and metadata onto the viciLogic server. Sometimes when upload occurs but the same project name has been used as before, project settings needs to be used to change the project name to a unique name. In this case, test A is added and the upload is repeated. And this time it will complete without issue. To save the file for creation of a prototype, Tools New Application is executed. This prepares the files for creation of a prototype GUI, and then save the project and exit. Then return to the folders and open the viciLogic Applications client-side applications, Remote FPGA Apps v2 folder, and GUI.exe. This opens another application window. Open the application, select the new design M21 test A, edit mode, and hit OK. A blank palette appears. Right hand button, add the background image, and browse to the combinational multiplexer M21 diagrams image and bring in the multiplexer image. Then add the I/O signals and toggle the dock on each to remove them from the periphery of the picture. Double click the left button and move them across and put them into position, mux in 1 here. Toggle the label first because the label is not needed because it's already on the picture. Double click and move it across into place. Same with mux out, toggle the label, move across the 0, but it's better as an LED in this particular case. So change the display from switch to LED and hit OK. The GUI is now completed. Save the project and then open the application again, this time not in edit mode. Select the application, M21, test A, not in edit mode. Because the files were already uploaded to the server, log on to the server with your username and password. A window is opened here in the side just to show that a configuration is actually occurring on a remote FPGA. You can see that that's happening on the FPGA on the right. All LEDs and 7-segment displays are 0. The GUI opens. Cell is the left-hand 7-segment display and one of the LEDs, LED bit 3. So assertion of cell has an impact on the FPGA. Mux-in 1 is LED bit 2 and 7-segment 2. Mux-in 0 is LED bit 1, and the output is asserted in that particular case. So you can play with the GUI and it operates on the real hardware, and this is the completion of the FPGA prototype.